Welcome to this lesson on laws of exponents, part one, which almost did not happen because my apartment is in a state of chaos due to construction work, and I almost did not find my pen to write on my slides, but the crisis was averted. Now, what I did with laws of exponents was I broke this into two lessons. The first lesson is more of a review of laws of exponents that you should know from Algebra 1. So if this video does not cover what you're looking for, be sure to check out the next video, which I should have posted within a week or two of posting this one. So it's very likely that video does exist by the time that you are watching this one. Now in this one, we're going to answer the question, when do we add them, multiply them, and subtract them? And in the next video, we're going to talk about exponents of zero, negative exponents, and what negative exponents in denominators mean. Please like and subscribe if you find this video helpful. It only takes a moment to click that like button. Check out the practice set for this video and drop a comment or question to engage. Before we go any further, though, we need to look at some vocabulary. And what I want to look at is bases and then exponents and powers. And just to keep this really simple, okay, if I write that there, that would be the base, sometimes represented by a b. Okay, we do that a lot in our formulas, so that's called the base, and that would be my exponent. So for example, in 3 to the 4th power, 3 is the base and 4 is the exponent. And we'll sometimes refer to exponents as powers. So you could say 3 to the 4th, 3 with an exponent, like the exponent is 4, or 3 to the 4th power, 3 to the power of 4. And so exponent and power are often used interchangeably, but we want to be clear about when we say bases, that's what we're talking about. We're talking about the thing that is being raised to the exponent. Now we need this because we will often say things like this. When we multiply like bases, we add exponents. And in order for you to interpret a statement like that, you need to be really clear about what we mean by bases and exponents. So, and when we divide like bases, so like bases, that verbiage means the same base. So in other words, if you had, say, 3 squared times 3 to the 6th, we would say those are like bases because the bases are the same. We really want to be on the same page when it comes to that vocabulary. Now, when do we add exponents? Well, answer when we multiply like bases. So we just saw that on the previous slide. When we multiply like bases, we add the exponents. And to illustrate this, I'm going to go with some very specific numbers and just illustrate this is why this law is a law. So if I had x to the 4th times x to the 3rd, okay, I'll write it out over here. X to the 4th times x to the 3rd. Well, x to the 4th is x used as a factor 4 times. X to the 3rd is x used as a factor 3 times. And then right here, we have a times sign. And so that comes down. And essentially what we have there is x used as a factor 7 times. So we have 7 x's multiplied in there. And our shorthand for that would be x to the 7th power. So when I taught Algebra 1, it's been a long time, I would have students do several of these, just like, 3 or 4 of them, maybe 5, I don't know, depends on the kids, and just have them do that. And then they would discover that law of exponents on their own without a teacher just telling them. And I think way too often a teacher might give you just a set of laws and then you try to memorize that set of laws. But if they don't make sense, what you do is forget them or you scramble the laws up. So sometimes I'm supposed to add exponents, sometimes I'm supposed to multiply them, I don't know, and you get them crisscrossed. So if you can go through enough examples like this, it becomes intuitive that x to the 4th times x to the 3rd would be x to the 7th. And so if I were to give you, say, x squared times x to the 5th, okay, that in your head almost you would picture, okay, that's 2x's and that's 5x, that's going to be 7x's, and then you begin to just add them. You see, oh, I'm going to have 2 and then I'm going to have 5 more, that's going to be 7. So the general rule here is x to the a times x to the b is x to the a plus b. And you might see a teacher do this where they write it as the adding. Okay, so you might see that. I don't typically do that. I figure we can add 4 plus 3, and I would rather for my students that this be intuitive, that it makes sense. And usually if I cover something like this and then I give my students a bunch of examples that are just adding exponents, everybody is happy. Everyone's happy. It's when the fun begins. You'll see. Now, when do we multiply exponents? Well, this is when we raise a power to a power. And this was where we want to know like the power, so an exponent to an exponent. So you've got here x to the 4th. So you have the first exponent, and then that whole thing is raised to another exponent. So again, we want to hash this out. Like we want this to make sense. So if I have x to the 4th raised to the 3rd power, well, that means I'm cubing something. And the thing I'm cubing is x to the 4th. So x to the 4th raised to the 3rd power literally means x to the 4th times x to the 4th times x to the 4th, because that's what it is to cube. Well, what we've done when we do that is we have changed it into the previous kind of problem where we are multiplying like bases. So in your head, you might do this and say, okay, I got 4 x's, and then I have 4 more x's, and then I have 4 more x's, and they're all multiplied together, and 4 plus 4 plus 4 is 12. And a much, much, much faster way to get to that 12 would have been to do 4 times 3. And we could see that maybe with something a little bit smaller. If I had x to the 3rd all squared, well, that would be x to the 3rd times x to the 3rd. So I would have 3 x's and 3 more x's, which would give me 6 x's total, which would be much faster to get by just doing 3 times 2. And same with the previous law. The best way to learn that is by doing a bunch of expansions out so that you can see like this is what these exponents mean and what they work, how they work. Okay, so the general rule is this: if you have a, that parenthesis got a little bit weird there, x to the a raised to the b, that would be x to the a times B. And I do want you to notice the placement of the parentheses. It is only the thing that is in the parentheses that is being raised to the exponent. So if I had, say, a 2 out front, that exponent does not apply to the 2. It only applies to the thing it's attached to, which in this case is the parentheses and anything inside the parentheses. All right, last one. When do we subtract exponents? Answer: when we divide like bases. And so for this example, this is going to kind of push into not new material, but a different way of thinking about it. So in this case, we're going to think of it this way. We have x times x times x times x over x times x times x. Now, implied in this, okay, implied is that x does not equal 0. So when we don't always see that. Sometimes we'll see it in the directions. It'll say assume that x or y or whatever is not equal to 0, because you can't divide by 0. So if x were 0, we'd end up with 0 divided by 0, and then the world ends, because you can't do that. But here, so we're assuming that. And then what I want you to notice is that there's a couple ways you could think this through, but what I usually have students look at is x divided by x. Well, we know that like 3 divided by 3 is 1, and we know that 5 divided by 5 is 1, and so we know that -2 divided by -2 is 1. We know that 0.2 divided by 0.2 is 1. Therefore, x divided by x is 1 is what I want students to conclude, but every year somebody will say X. But it's a 1 because anything divided by itself is 1. Like it can go into itself one time. And what we've got over here is a bunch of 1s. Okay, and so 1 divided by x divided by x is 1. And so what we really have there is 1 times 1 times 1 times x. And that's why they cancel. So I'll often have students say, well, the x's cancel, but we really want to know why the x's cancel. We don't want to just cancel stuff. So we know that they cancel because x divided by x is 1, and I am left with simply x, which is x to the first power. And a faster way to get there would have been to do 4 minus 3. Now, just to illustrate this, again, now I know I have an illustrative example and I'm kind of going overkill, but we need to see this enough to digest it. So suppose I had x to the 5th divided by x squared. Well, that's x used as a factor of 5 times, x used as a factor twice, and then you have those 1s. X divided by x is 1, and now I'm left with 1, 2, 3 x's, so x times x times x is x to the 3rd, and a faster way to have gotten there would have been to do 5 minus 2. And again, I know I sound like a broken record for those who know what a broken record is, but you want to handle enough of these so that you don't have to think really hard about what you're doing. You should be able to kind of almost envision that expansion in your head so that it makes sense. Now, the general rule here is x to the a divided by x to the b is x to the a minus b. And it is always the numerator minus the denominator. It is not the bigger number minus the smaller number. And that is going to become critical in the next lesson, that it is the placement of the a and the b, not the value of the a and the b. Nothing about this statement right here says anything about the specific values of a and b. It is simply going to be a minus b. So do remember that. So what happens when we mix them up? Well, the fun begins. Now that might be my idea of fun. This is also where the wheels can fall off. So if I only gave you one version of these problems, then and all you had to do is add, okay, like these are adding problems. But in reality, most of these problems are going to come to you in some kind of combo variety where you have to engage order of operations, some critical thinking to get to the end. I like to think of them as puzzles to solve, and we're trying to simplify them down to like the easiest looking thing. And there's more than one way to do them. So a lot of these problems, you will have options for what you want to do first, particularly after we get through the second exponents lesson. So let's take a look at this first one and kind of make sure we understand what we're saying. So we do have the fraction, so we have the division. And up here in the numerator, I have parentheses, and the parentheses are being raised to the 3rd power. Now, there's a short way to do this, and then there's a little bit longer way, and it's very, very important that you, the doer of the math, understand what's happening. So I'm going to do this the short way, and then off to the side, I'm going to show you the reasoning behind it. Well, we know that if we have a power raised to a power, we multiply the exponents. What's not as obvious is that 3 is 3 to the 1st power, and x is x to the 1st power. So when you raise the power to the power, you multiply all of those exponents. So you will do 3 to the 1 times 3, which would give you 3 to the 3rd. And then you do the same thing with the x to the 1 times 3, which would give you x to the 3rd. And then y to the 2 times 3. 2 times 3 is 6. Okay, that's using the law outright. Now, if that felt weird to you, or you're like, I'm not sure I followed all that, I want to do this a different way off to the side here. So remember that to cube something means to use it as a factor 3 times. And what we're cubing is the parentheses. So that whole group of things is what's being cubed. So what that really is 3xy squared times 3xy squared times 3xy squared. And now you can see, oh, yep, like if I reorder that, now it becomes more apparent what we got going on. So we have 3 times 3 times 3, which of course is 3 to the third, and then we have x to the third, and then we have our 6 y's because each of those y squareds is 2 of them, and so we end up with 6 of them. Now that is, again, it's important for you to see that it is not good enough to just have a law and say, well, I multiply exponents here. We want that law to make sense to you. Now, this problem can be carried out further. So I'm going to go ahead and erase my scratch work. If you need to see it, of course, pause the video to copy that down. I'll give you a moment to do that. All right, hopefully if you were going to copy it down, you've got it down by now. If not, you can rewind the video. A little bit more inconvenient, but we can with it. We can do inconvenient things. Okay, so we can do a little bit more with this. 3 to the third power is 27, and then we have x to the third, y to the sixth. And what I tell my students to do is think of this as 3 like mini problems. And so the first mini problem has to do with the constants. You have 27 divided by 9. The second mini problem is the x to the third, and the third mini problem is y to the 6 over y squared. Now what I did there was I rewrote it kind of like spaced out, and that just creates visual separation. So if you're a learner that needs to see things a little bit more separately, you can see it there. And now it turns it into 3 smaller problems. Well, we have 27 divided by 9, that is 3. X to the third, like we're not doing anything with that. And then we have y to the 6th over y squared. Well, remember we would subtract those. So 6 minus 2 is 4. I don't know if I said 4 earlier. I might have said it thinking of the answer. It's y to the 6th over y squared, and then 6 minus 2 is 4. If I said it correctly twice, I guess you can live with that. Just every once in a while, I know that I can misspeak when I'm doing these videos, and I don't even know I did it because my eyes are looking at something and my brain is one step ahead or behind or whatever, and I say what comes out of my mouth is not what I'm pointing to. So, all right, so let's take a look at this second one. So the second one has a lot going on in it. We have some multiplication, so 2x squared times, and the thing that we're multiplying there is a 3x to the third all squared. And then in the denominator, we have something interesting going on where we have 6 times, and then we have the parentheses isolating the x to the third, and that's being squared. And what that means is the 6 here is not being squared. A part of this example problem is to draw your attention to the fact that if the number is in the parentheses, then it is included in the group and will be raised to the power. If the number is not in the parentheses, then it is not included in the group and will not be raised to a power. Now, what I used to tell my students doing this is when in doubt, expand it out. So you can use all the laws. Okay, and so if we use the laws, it's going to look something like this. So we have that, and then we know this is 3 to the first power. So 3 to the 1 times 2 is 2, so that'll be 3 squared. And then we'll have x to the third power squared, and 3 times 2 is 6. And then in my denominator, the 6 is not included in that mess. And then we have x to the 3 times 2, which is x to the 6th. You could also do what I did before and envision that as 3x to the third times 3x to the third. Okay, that will also work. Now, from here, you actually have some options. You can combine all of the x's in the numerator Okay, and so we could do this. We could do 2x squared times 9 times x to the 6th over 6x to the 6th. 2 times 9 is 18. And then when we multiply like bases, we add exponents. So 2 plus 6 is 8. And then do those mini problems. So you have 18 over 6 is one of them, and x to the 8th over x to the 6th is the other one. 18 divided by 6 is 3, and then we would subtract the exponents there to get 8 minus 6 is 2, and it simplifies to 3x squared. But you could also go a different route with that. You might recognize that you have x to the 6th divided by x to the 6th, and you might cancel those out saying that's equal to 1. If you picture all those x's strung out, you can see that those are going to cancel. And then you might do this. This will be 2 x squared times 9 over 6, and then do the 18x squared over 6, and then just do the 18 over 6 is 3. Regardless of the path you take to get there, the answer to this, the simplified answer, is 3x squared. So there are multiple paths to take. I don't even think those are the only two. So you could like kind of spot some things and do things differently. Things you can't do is you cannot do 2 times 3 is 6 and then try to cancel out the 6's. So you've got to follow your order of operations and make sure that you can carry out the exponent here before you do the multiplication. That's a very common mistake. So be sure that you check out the practice set. As you can see, these can get kind of involved and challenging, and there's lots of different routes you can take. Please give this video a quick thumbs up if it was helpful. Only takes a moment to say, hey, this was helpful. Click on the practice set for this lesson. You do want to practice this before we layer on more stuff, and then drop me a comment or a question to engage. And I hope to see you in a future video.